we're going to focus mainly on analytical geometry and trig. And then we're also going to try and fit in a bit of equations and inequalities. And then I put some extra topics that students have been asking about during the week. I added them to our list of material. After the lesson, you'll get a full memo that has all the answers to the questions. But in the actual session today, we're going to try and do these exam questions. Okay, so let's start by having a look at a typical exam question for analytical geometry. And so we're going to start there. That's going to be the starting point. Now, before we start the question, I would like you to indicate in the chat, give me a thumbs up if you can see it nice and clearly. So in the chat, I want to make sure it's visually nice and clear. Awesome. Okay. So before we do this question, I thought it would be a good idea to just go over some of the basic knowledge that may come up in this section. So just to remind you of some of the skills that you'll need. So we'll be back to this question in a second. But if we look, and there's a couple of bits of knowledge that I haven't covered yet in the unit. And so I thought I would just point these out. So in class, in the unit we've been doing lately, there's clearly knowing how to use the distance formula, the midpoint formula, and the gradient. That's important. Then you need to know that parallel lines have equal gradients, which we've also covered. I haven't spoken about this other bit yet, but I'm sure many of you may have come across it, is that if we have perpendicular lines at 90 degrees, their gradients are what we call negative reciprocals. And so if I have one of these, if, for example, the gradient here was 2, and I know this one over here is perpendicular, the gradient here would be negative 1 over 2. So we flip it around and we change the sign. So that's something that I want you to be aware of today as we go into this first question. The other thing I want you to be aware of is the equations of straight lines. And we've covered that. This is the standard form of a straight line. And I also want you to be aware of this formula, tan of theta equals m, which is for the angle of inclination. So these are the basic bits of theory that you need to have a go at this question. All right, so I'm going to ask you guys to do these first 3 as a group. And then once you, there's one other little bit. Is ABCD a rectangle? Use your answer to this to justify conclusion. I haven't spoken about this before, but how would we show that something is a rectangle in coordinate geometry? Does anybody know? And put it in the chat if you feel like you have an idea. So the question says, is ABCD a rectangle? How would we be able to prove something is a rectangle? And if you have an idea of how you would do that, just put it in the chat. Otherwise, I'll tell you in a moment. But I want to see if anybody, or if you would like to jump on the, if you're willing to give an audio feedback, put your hand up and just let us know with your voice. AD equals AC, almost. When 2 pairs of lines are equal, you're on the right track. You're almost there, guys. So if you're going to prove, give it a moment more. Does anybody want to raise their hand and give us anything? Collinear, okay, almost. So if we want to prove that something is a rectangle, what we need to do is we need to prove that the diagonals are equal in length. So for example, ABCD is a quadrilateral, or it's a parallelogram. They actually tell us it's a parallelogram. If you want to prove that this thing is a rectangle, we have to prove that this diagonal over here is equal in length to this diagonal over here. And because I haven't explicitly mentioned that before, that's something which you need to be aware of. Okay, over to you guys. I'm going to give you a bit of time. I want you to answer the questions 1.2.1 to 1.2.3, and then I'm going to give you some feedback. And if you have any questions, put your hand up. I will take audio questions now. If you have questions for the chat, pop them in the chat. but we're just going to do this. And this is from an old exam paper that I was involved with. So let's see how you do. Once you've got your answer for AC and BD, pop it in the chat, and then I will, okay, so I see some answers going through. That's good, guys. Keep them coming. Some people have got answers for AC. What do you get for BD? And do you notice anything about them? That is an important question too. Okay, so most people seem to be getting the square root of something, which makes sense. It's the distance formula. AC, BD. So those who have got the square root of 145, you are correct. Now, what do you get for the length of diagonal BD? Okay, so a lot of you are getting the square root of 233. And so I will show you full working in a second, but just for the moment, that is correct. And so what does that mean about 1.2.2? Is ABCD a rectangle? And then can you find the midpoint of E of AB? And can you find the midpoint F of AD? So let's say here 1.2.1, done. Okay, so I see some people in the chat are already saying that they're making a decision. They're saying ABCD is a rectangle or ABCD isn't a rectangle. I want to know, do you think it's a rectangle or do you not think it's a rectangle? And why do you know? Why do you know, basically? What's your reason? Okay, guys, if we could just, I'll put you on mute all if necessary. So just to remind everyone what we're doing, we're working on the first 3 questions. I'm going to hit mute all. And then I'd love for you to tell me if it's a rectangle or not. And then also I want you to put what are the midpoints for 1.2.3. Okay, so for the answer for this one, 1.2.2, it's not a rectangle because diagonals are not equal. if you look above, AC is the square root of 145 and BD is the square root of 233. And so because these are not equal in length, it's not a rectangle, and because the diagonals are not equal. And then the last bit is for 1.2.3, what do you get for your midpoints? So when we're calculating E and F, we first have to make sure we know where they are. So E, the midpoint of E of AB, so E is going to be somewhere on this line up here. So find the midpoint E of AB. So E is going to be up here. And we need to find it. And then to find F, F is on AD, so F is down here. And so in order to find 1.2.3, so we need to find A, so minus 4 plus 6 over 2, and is the X part. And then minus 1 plus 5 over 2. And so E should be 2 over 2, 4 over 2, which should give you 1, 2. So you should get the point 1, 2 for E. And you should also get for F, using a similar idea. Remember where F is on AD. So F is over here. You need to use the points A, and you need to use the point D.
Mr. S?
Yeah.
Muziwake is asking if you could please explain 1.2.2 again.
Okay, so why don't I put the full memo that you guys are going to get afterwards on the screen, and it might help a little bit just to almost allow me to work a little bit more from that. So if I go, so I'll do that. I'll bring this across. Where did it go? I will in a moment. We're going there. Oh, sorry, wrong thing. Well, let me move across. So which question was it, Lebo?
1.2.2.
Okay, so the only thing we had to do with 1.2.2 is, let me see. So here's my answers for this one over here, 1.2.2. You first have to just make sure that you agree that the length of the sides are different. So once you notice that they're different, diagonals have different lengths, therefore it can't be a rectangle. That's the main idea that I did. And so I think, does that help? That's the only focus that you need to do. And then for E and F, we should have got the coordinates 1, 2, and minus 3, minus 9 over 2. That's the main thing we should have got. Okay, so guys, what I'm going to ask you to do is, while I just get myself a little bit more sorted out, can I ask you to continue with this question? And so what I want you to do is I want you to try the answer for 1.2.3. I'll just put it up on the board. Should have been 1, 2, and F, you should have got minus 3, minus 9 over 2. whilst I'm answering student questions, I'd like the rest of us to try and do 1.2.4 to 1.2.6. Okay, so if students have, maybe they could, so Lebel, are there any other questions from the students?
Not so far, no, not in the chat.
Okay, otherwise, if they just raise their hands, I will try and assist them. But for now, everybody should be moving on to the next part of the question. So join E and F. And remember, we've got E and F already. Find the length of E and F, and then pop your answer in the chat. Okay, Notile has got an answer for EF. So that's great.
Mr. S?
Yeah.
Kosi is asking if you can please explain 1.2.3.
Okay. So while the others are working on stuff, 1.2.3 says find the midpoint E of AB. So that would be here. And so that's the point E. So to find E, what I need to do is I need to find the points that make E, which is A and B. So I'm focusing on these two. I'm adding the two X coordinates, and I'm dividing by 2, and I'm adding the two Y coordinates and dividing by 2. Now I've still got to clean them up because I've got -4 plus 6 is 2 over 2, which is the same as 1. And -1 plus 5 is going to be 4 over 2, which is 2. So that's how I got E. How I got F, the only difference with F is on the section AD. And so I need to focus on slightly different sections. So F is on AD. I need to focus on A and D, which is here and here. And so I'm going to add the two X coordinates. And I'm going to add the two Y coordinates, -1 plus -8 over 2. And then if I clean that up a little bit, -4 -6 over 2, so -3. And then -1 plus -8 is -9, but it's -9 over 2. And so I hope that helps a little bit. So that's how I got my answers for E and F. Okay.
Mr. S?
Yeah.
I'm sorry. Do you mind giving the formula, the distance formula again? Because there is a question about 1.2.1.
So the distance formula is just going to be that basically. Let me just. So it's basically the change in X squared plus the change in Y squared, then square root. And so that's to find the length EF. Now, what's important is that EF is actually something that we've just worked out in the previous question, right? So here was E and here was F. And so what they're asking us to do is to find that.
Mr. S?
Yeah.
There's another question. Is it better to leave the answer in surd form or should you convert it and write it in decimals?
It depends on what the teacher asks. If you're using it in a later calculation, I prefer leaving it in surd form, because if you round it off during the question and you use it later, it gets inaccurate. However, if it's a final answer and the question that at the beginning of your exam, they say round to 2 decimal places, you have to just follow instructions. But my preference is to leave it in surd form because it's more accurate. Okay, so keep those answers for EF coming. And then also I want students to say what the gradient is for EF and BD. Those are the two next questions. So let's see how that goes. And so I will actually work out EF in front of you. If I look at my, the EF is sitting up here, the coordinates EF. And so how do I use this to work out what it is? Well, let's go 1 minus -3. That's going to end up being 4. And then this is going to be 2 minus 9/2, or 2 plus 9/2. And my final answer for EF is going to be a little bit messy, depending on how you let's have a look. Get my calculator out here. So my calculator gives me 58.25 if I leave it in decimals. So 58.25 or 233/4. Okay. So that is the answer to those two. I'm just going to clear the board a little bit of some of the old stuff so I have some more space. I see additional answers are coming in, which is great. So 1.2.5, we have to find the gradient of EF, which is what we've just done. We use a different formula, and we have to find the gradient of BD. So I want the gradient of EF, and I also want the gradient of BD. Okay, well done, guys. I see good stuff coming through in the chat. Now, EF is parallel to same gradient. Yes, Cameron, well done. Okay, some of you are jumping ahead there. And then have a look at 1.2.6, which is the interpretation question. So the gradient of EF, remember the formula for gradient is just change in y over change in x. So what I'm doing is I'm going to say 2 minus 9/2, which is that, change in y, and then 1 minus -3. And that should give me 2 plus 9/2, and that would be 4. And after all that, we should get as the gradient 13/8. Now, what about BD?
Mr. S?
Yeah?
Sorry to interrupt you.
Fine.
Could you please explain how you calculated the distance for EF, why the sign became a plus 9/2 and didn't stay?
Oh, okay, so it's the gradient formula. So, but that's fine. What you have is you have a double negative here. So 2 negatives give you a positive.
Where you did the distance, when you were calculating the distance for EF.
Okay, so back in here.
Yes.
So if I look at EF, the 2 points, it's the same idea. If you look at the top part of if you look at this bit, if I go 2 minus -9/2 becomes 2 plus 9/2. So it's just the fact that when the distance formula, it's y2 minus y1. When I say the thing at the top minus -9/2, it becomes a positive. The same way for the first bit, for the x bit, I went 1 minus -3, which became 1 plus 3, which is 4. Okay, so I hope that helped. Okay, so now what we have is BD, and for BD, I am going to just say that using what is, in the question, we know if we go through the working out, you should get B and D. So basically it's going to be 5 minus 8, and then 6 minus 2, which gives me 5 plus 8, which is 13, and then 6 minus 2 is 8. So you have found the gradients are the same. So in the last question, is there a relationship between EF and BD? Explain your answer by looking at the answers to the question above. And someone said already, but I'd like you to notice, what do you notice about EF and BD? What do you know based on what the question has shown? I want you to pop it in the chat, please. They're equal. Okay, so what does it actually mean if the gradients are equal? The lines must be parallel. So BD and EF must be parallel to each other. Yeah, perfect, guys. You're smashing it. Well done, guys. Okay, so that is a typical exam type question on analytical geometry. Now, because it's past now, what I'm going to do is there is another question on analytical geometry, but I'm not going to do it today because I think we want to spread our time evenly. But just to let you know, you will get the answers for this question and the other one after the lesson. And I just want to get a feel quickly of the class before I, take a little break, or before we kind of go on to the next. Before we go on to the next section, I want to just get a feel for how the class is doing with the polls. Lebo, I think are you host? I can't seem to access the polls at the moment. Could you maybe make me host? Just so I can do a quick poll of students.
Yes.
Or unless I've gone crazy, but I don't seem to be able to. Or can you launch the pacing poll just so we can get a feel for how students are doing while I set up the next topic? While we're doing that, guys, I want you to do a little brain break for me. So we finished the first little part of the lesson. And while we do that little poll, will you also do this little brain break for me? Just to let our brains unwind for a second. And then once you've got the answers for this brain break, if you feel like you've got an answer, like what the red apple is, what the banana is, just pop it in the chat before we go on to our next topic, which is going to be trigonometry. Okay, so the first answer for the red apple has come in. Keep those polls coming, guys, just so I know roughly what speed we need to go at. So you're quite right. The red apple is going to be 10. So I think a couple of people have got that. So what does that mean about our bananas? Yep. So the bananas are going to have to be 4 each. Well done, Nowazi. And Pabalo, is that your final answer? Have you really got the final answer? Oh, you have. Yes, you have. Okay. So the final answer is 16. Well done to Pabalo, who seems to get that pretty quickly. Tsapang, oh my gosh, Aaron, you guys, Emmanuel, Kozi, Notile, wow, you guys, wow, Cameron. Okay, so clearly I need to make them harder is the moral of the story. Okay, guys, so to let you know, the pacing seems to be good for the majority of students. What I'm going to suggest is if you want more practice on analytical geometry, you can have a look at the second exam question over here. But what I want to do is just give you one little bit of guidance before we move on to trig, is that in this particular question, 3.5 is a very nasty one, and it's only really useful if you know something. The angle of inclination of this line over here, you can work out quite easily by using that tan theta equals m formula that I spoke about during the week and also mentioned at the beginning. What you need to know to do this question is that this line over here, because it's parallel, it will have the same angle of inclination. Okay, so even though you can't see it, because these are parallel, they must have the same gradients. So for example, I don't know what the, well, I can work it out, I guess. So let's go 3 minus 0 over 12 minus 3. And so this is 3 over minus 9, which is, no, I must have done something wrong there. 3 minus 0 over 12 minus 3, so it's positive 9, 1/3. Now, because these lines are parallel, it means they have the same gradient. But if they have the same gradient, they also have the same angle of inclination. Okay, so give me a thumbs up if you understand what I mean. I want you to do this question by yourself later today, and then you can mark it yourself. But I didn't want to give you this question without pointing out that rather tricky bit that, you know, it might confuse a lot of people. So give me a thumbs up if you understand what I was talking about there. No? Okay, so basically, earlier in class in the week, we spoke about something called the angle of inclination, which is part of this question. The angle of inclination is the angle a line makes with the positive x-axis. So in this question, it's how big is that angle? And the way we solve for that angle is we use the formula tan of theta equals whatever the gradient is. In this case, the gradient we work out to be 1/3. So we write that formula. Now, if we use trig, and we're going to get to trig in the next part of the lesson, all right, can you go to your calculators now and go shift tan 1/3, and what do you get? I'm actually doing question 3.3 right now. So calculate the magnitude of theta. I see someone's hand is up. Whose hand is up?
Sepang. Well,
Sepang,
it went
do you want
down
to ask?
now.
Okay. So, all right, perfect. So you should see you get 18.43 degrees. So using that formula, you know that this angle of inclination is 18.43. Now, the tricky bit that I wanted you to know about to do question 3.5 is that this yellow line up here, because it's parallel, it must also have the same angle of inclination. And you'll see this in the answer. Basically, this angle over here will be equal. But I don't want to get dragged down that rabbit hole. I just didn't want you to get worried about that question. An important thing in analytical geometry is this tan of theta equals m formula. And I will be speaking about this more on Monday because I only started with this on Thursday, but it does come up in this exam question here. Yes, you do, Nizole, that's exactly right. All right, but I don't want to spend the whole lesson on analytical because I know a lot of people want to talk about trig. And so you can do this question by yourself at home later on to practice. What I want to do now is I want to start with a trig question. And this is a typical trig question from an exam. You can see it's worth 10 marks. And the only thing you need to bear in mind is SOH CAH TOA. And I want everyone to try and do this. Let's try and do this bit first. Once you've done that bit, after you've done that bit, I will give you some feedback and then we'll try the next bit. But over to you guys. Try and do this trig question and then pop your answer in the chat. If you have a question you'd like to ask, put your hand up and I'll talk to you live. I'd love to hear some voices. It would be awesome to hear your wonderful voices. Oh no. Leopold, can you look at maybe finding out how I closed the poll? I'm not quite sure how I put the poll to bed.
I closed it already. Is
Oh,
it
did
not
you?
closed? Yes, I
No,
did.
okay. Perfect. Thank you so much. You're a star.
Okay.
Okay, so one of the things that might be helpful is to put information on the drawing. So BC is 11, AB is 9. And you're right, some of you are saying, can you use Pythagoras? Absolutely, you can use Pythagoras if you want. Yep, you can use trigonometry or Pythagoras, because this is a right angle triangle. So Nizole, on the previous question, 3.4 and 3.5, the memo will show you how to do them in absolute detail. I think it's better if we balance our time today between 3 topics than try and obsess about one. But even if we want in class on Monday, I can go through that question maybe a bit more in detail. But for now, most of us, I think, want to do a little bit of everything today. Okay, so AC is equal to, well, the square root of 9 squared plus 11 squared, because Pythagoras. Which should be the square root of 202. Perfect. Now, can you find for me what the value of the sine of C is? So in trigonometry, what we often need to do is make sure we give our sides our name. So we worked out that was square root 202. This is the hypotenuse. Now, if I'm asking you for the sine of C, then this is going to be the angle that I'm interested in, which makes this the opposite, and it makes this one the adjacent. So what is sine of C going to be equal to? I want to see a few more students answering in the chat about what they think the sine of C is. So the sine of C is going to be O over H. And since I know on this drawing, C is here and opposite C is that. So we should have sine of C is 9 over square root 202, which if we put into our calculators in a moment, get that out of the way, you should get 0.63. And all I was doing, guys, and I want to make sure you see this, is I was using the H down here, and I was using the O up here. So we get 0.63. Okay, now it gets a little bit trickier in the next part because I want to point out that the angle that you're dealing with is not in the same place always. So it's asking for the cos of A here and the sine of A there, but it's also asking later on for the tan of C. And I want to see what you can do to get there, to try and do that. And if you're confused, I'd love to have a conversation with someone. If they put their hands up and you ask a question, I will unmute you. But for now, I'd like everyone to attempt 4.1.3. So the cos of A, it's still the same angle, except ask yourself, shouldn't the cos of A be, what's cos? Cos is A over H. And so for this drawing, the cos of A, oh, this is what's sneaky. Okay, wait. Let's rub all this out for the moment. Cos of A means this angle over here is in focus. So even though this side over here, you know that this stays fixed. It's square root 202. This is H. This never changes. The O will change its side depending on which angle I'm talking about. Because this is going to be, so I'll put here, this is, BC is 11, but this is now going to be O. And this one over here, this is now going to be A. So let me get rid of some of the working out that was here already. So the cos of A is going to be 9 over the square root of 202, which is a bit weird. And the reason it's so weird is look at the question. It says cos of A, which means A is in the angle A is in the driving seat. So this thing over here is what makes everyone dance. Now, opposite A will be O, the opposite side. And I suppose the A of the adjacent and the letter A are making it a bit confusing. Okay, but let's keep going with this. Let me do it a little bit lower down so it's not in the way. So we've got 9 over square root 202 plus the sine of A. Luckily, it's still sine, so the sine of A is going to be 11 over square root 202. And the reason that is its sine is just over H. And then the last bit is the tan of C. Now, the tan of C, I'm going to have to rename my triangle again because the thing that's in focus is no longer the A. The thing that's in focus is the C, which makes this O and this A, and this one stays exactly where it is. So what is the tan of C? It's going to be 9 over 11. Now, guys, this is unnecessary. Well, now that I do it, this is unnecessarily confusing because of the A for adjacent and the letter A, B, C. So if you're feeling a bit confused with this, don't stress. I can see how that would be a bit tricky. The main focus of this question is trying to show you, if I talk about angle A, the opposite will be opposite angle A. If I'm talking about the tan of C, then the angle C will be in the driving position. Lebo, did I see someone's hand go up for a question?
Yes, but it's down now, so
okay.
I don't know.
So we should have got, as our final answer, it should be approximately 1.27 or 1.25, somewhere around that should be the final answer for 4.1.3. And all I want to say is that we just had to substitute in these values, but doing that was a little bit sneaky. Now, the last bit is how do I find the value of the actual angle A? So when I look at the angle A is up here. Okay. Now I want to solve for this angle and I want to make a trig equation to do this. I think the trig equation that I will make will be that the tan of A is equal to 11 over 9. The tan of, okay, so tan of A equals 11 over 9. Now, if I know the tan of A is 11 over 9, I can use my calculator going backwards, or I can use inverse tan to figure out what A is. And I go shift tan 11 over 9. What do you get as your answer for that? So I see a lot of people who are getting somewhere around 50. Let me just check my memo and also check. Yep. So rounding can come in, but you should get, according to my memo, 50.70, which looks about right if you look at the drawing. So if we look back at this question, and I encourage you guys all to look at the memo afterwards, right? So I'm not going to spend too much time. I know there were some tricky bits in here, but question is checking, do you know the definitions for trigonometry, your basic definitions? So guys, you're right. A lot of you said 50.7 to 50.7 or 50.71. That seems great to me. Yeah.
Sorry, I don't know if you noticed in the memo that it was written tan A instead of tan C, so that might cause a bit of confusion.
Aha. Okay, I'll have a look at that if there's any, but the answer seems to be correct.
Yes, the answer is correct.
Yeah, the value of A. Cool. All right. Whose hand is up? For some reason, I can't see the person. Oh, there we go. Tsepang. Let me ask a question, Tsepang.
So for 4.1.4, did you have to use 10 or could you use any other?
You could use any other trig ratio, but you should have got approximately the same answer.
Okay, thank you, sir.
Cool. All right, let's do another trig question that is very common in grade 11. If you want to take it, yeah.
I'm sorry, there's another question from Aaron.
Okay, Aaron, will you unmute? I'm going to unmute you. Go ahead.
So on 4.1.1,
yeah,
do we keep on changing the positions of the adjacent and the opposite?
Okay, why did I do that? The reason I did it was in trig, if the question says, let me just take away a lot of the clutter. Can you see that in 4.1.2, it says the sine of C? Now, in this particular triangle, if I want to know the sine of C, I need to give that angle priority, and I name where the opposite side is, opposite that angle. Now, and everything else gets its name from that point onwards. So when the question refers to the sine of C, I have to have O in the position it's currently in now. However, if the question says I want the sine of A, well then this angle is in the driving seat, and this has to be named O, and this has to be named A. The H will never move because it's opposite the right angle. Now, what made it very confusing in this question is the letter A for adjacent has nothing to do with the corner angle A. And I think that's what maybe would have caused a bit of confusion. But it is important to realize if a question says the cos of C, then we need to start from C and name our opposite C. Go ahead, Erin. Is there anything more?
Yes, thank you, sir. I understand now.
Perfect. Okay, so let's do this question over here. I want to see what you can do. This is a typical grade 11 trig question. And it gives you the cast diagram. And I just want to see what people can get for these two questions. Also, my tip is you have to reduce this trig. You have to reduce this trig expression using your knowledge of the reduction formula to help you. But over to you guys. See what you can do. While you're thinking about it, I'll just give you a little hint. Whenever you do trigonometry, you need to have three sides of a triangle. And so at the moment, what sides of this triangle do you know and which ones do you not know? Let's do it. What is the cos? So in this case, you'll notice that we have the angle alpha. And I want to know what is the cos of alpha from what's called, this is the cast diagram. What is the cos of alpha going to be? And what is the tan of 118 minus alpha going to be? If you've got a question, pop your hand up. I'd love to hear your voice. So the point P is minus 5b, which means the x coordinate here, this must be minus 5. And it tells me in the question that this is 13. So I need to know what this thing is over here. But this is a right angle triangle. So how can that help you? So what I get is I get that B is 12. And then if I ask myself for the cos of alpha, now, sometimes in these questions, SOH CAH TOA can also be written in the form where this is a Y, this is an R, this is an X, R, and this is a Y, X. That also does happen. So the cos of alpha, given this, it's just going to be minus 5 over 13. So think about this, guys. If we had to name our, so we've got our triangle, we've got alpha, the angle. If I want to know what cos is, let me look at cos here. Cos is A over H. In my particular triangle here, isn't this H? Isn't this one O? Isn't this one A? So X is on the, or A is on the x-axis, the adjacent is on the x-axis. So essentially what I have is the Y is the O. And so because cos is A over H, on my drawing, cos should just be minus 5 for the x-axis and then 13 for the hypotenuse. Okay, so that is for that one over there. Are there any questions? I sense a bit of uncertainty. So if you'd like to raise your hand and ask a question. For the second one, what can we do for the tan of 180 minus alpha? How would we reduce that? And then how can we use the drawing? Okay, 5.1.1 again. Okay, so first of all, I am going to remove this working out over here, because basically what happened is I used Pythagoras to work out that the y was 12, that basically the point P is minus 5, 12. Give me a thumbs up if you understand how I got the 12, because I want to make sure I've got everybody. So give me if you understand how I got the 12, give me a thumbs up. Okay, so I used good old-fashioned Pythagoras. Okay, so everyone's with me at that point. It's somewhere after that where we got a bit pear-shaped. When I ask you for the cos of alpha, it's referring to this thing in yellow over here, this angle, but this angle generates its own triangle in quadrant number 2. And in some ways, this alpha actually generates this triangle with this like reference angle inside it. But for our purposes, if this little angle over here with the horizontal is being made, opposite that is O. Okay, so what's O is going to be 12. Now, because it's going along with the y-axis, sometimes we would say that it's just y. Can you see how it's in line with the y-axis? So sometimes when people do trigonometry, instead of using O, A, and H, they use X, Y, and R. And so that's why here, sometimes you'll see instead of the hypotenuse is 13. It's opposite the right angle, but sometimes we will call that R. And then the A, in this case, is along the x-axis, so sometimes we call it X. So I want to make sure you understand. Do you understand? Give me a thumbs up if you understand why 12 is O and why minus 5 is A, and y 13 is H. Give me a thumbs up if you understand how I made that connection. If not, give me a thumbs down. Okay, so that's the important bit. Okay, so you're with me so far. Now, I have to now evaluate the cos of alpha. Now, the cos, if I go back to this thing here, cos is A over H. So what's A? Well, A is minus 5. And what's H in this drawing? H is 13. So we get minus 5 over 13. That's how I got that. All right. So now the second question, and I know we're not perfectly there yet, guys, but we'll just keep practicing this, so don't stress. I want you first to put in the chat for me. I want to break this into 2 parts. Can you use the reduction formula on tan of 180 minus alpha? How would I reduce that? First, reduce that. Then we can work out what that is without a calculator. Because remember, this question actually said, work out these values without a calculator. So in the chat, what is the tan of 180 minus alpha? We have to go back to our reduction formula days and ask, what quadrant is 180 minus alpha in? I think it's in quadrant number. Okay, so tan is in the second quadrant. So it's going to be minus, I see those answers flooding in, guys. Well done. Minus tan alpha. Okay, so we've reduced 180 minus alpha. If you're unsure about this, I did some wonderful videos in trig working with the reduction formula. So that's how we get minus tan alpha, but that's not the answer, guys, because we have to go back to my question originally and go, what is tan? Well, it's minus O over A. In this particular question, what is O? Well, I think you worked out O earlier on in the question. What is A? Well, I want to give you guys a chance to get this. What is minus tan of alpha going to be as a final answer? I filled in this step. I want you to help me work out what this next bit is. Okay, so you have to substitute in. You get minus, and then you have O was 12, and then you have A is minus 5. Oh, guys, but you have a double negative here. So you have minus 12 over minus 5. So you end up having 12 over 5. So have a look at that double negative. Do you agree with that? So think about, you had the minus from reducing the tan, but then you also had a minus 5. And so when these two negatives interacted, you got your 12 over 5. Okay, cool. This is another very typical exam question. Okay, I'm going to move on because I know that we want to talk about trig equations. Now, before we do these trig equations, this exam question, yeah.
I'm sorry, before you move on,
yeah.
Can you please explain the double negative again? There's some confusion.
Okay, so in this question, there's a negative that comes from the negative tan, the reduction, basically. So that's the first negative. But then when I substitute in for A, that was minus 5 above. So when we have two negatives interacting, they have this effect that they cancel each other out. And so minus 12 over minus 5 is going to be the same as positive 12 over 5. It's a principle in mathematics. Like if I have minus 1, I get plus 1. Okay, cool. Now, I want to give you, I did quite a lot of work on this in the module, but I want to just remind you of the method. Now, each of these are trig equations, and what they are telling us a certain range in which they want the answer, and they're trying to make it quick and simple. That's why it's only worth 2 marks. I do think it's worth for us trying to write out the general solution some of the time, just so that we get the hang of it. And I think I'm going to do actually, I tell you what, I want everyone to try and do these first two over here. Just try and do these first two. And then once you've tried to do them, if you're stuck, I want you to raise your hand and I'll talk you through it. But I just want to see, can you solve these trig equations? The method I used in class is I said, ignore negative signs, ignore negatives, and then find a reference angle. So that's step one. And step two was decide on quadrants where, for example, where tan is positive in the first question, or in the second question where tan is negative. That's the method that I want you to use from earlier on in that I showed you in the classes. But some of you might be new. You might not have been here for those classes. So I'd love to have a conversation with you while the others are working. Just pop your hand up and let's see how that goes.
Mr. Ace?
Yeah.
There's a question from Tapang.
Okay, cool.
Go
ahead,
okay, so this is the previous question that we did.
Okay.
Why don't we shift our answers? Because if we're looking for that specific angle.
Okay. Shift your answers in what way? Do you mean?
So if we were looking for the tan alpha, right? We're looking for the angle alpha.
Okay. I know what you're saying. I'm not going to go into a deep discussion about that right now. All I can say is this. If you are dealing with a question like that, always, the tan of 180 minus alpha, don't be distracted by trying to find that angle on the diagram. Simply always take the algebra and reduce it using the reduction formula, and then sub in the values. Do you know what I mean? Like as a principle. So just always reduce, take that a tan of 180 minus alpha, whatever fancy trig expression you get, reduce it first using the reduction formula, and then you go to the drawing and get your values. Because if I go into any more detail on that, it's going to cause confusion. And I know that process will work really well. Okay, Lorraine.
Hi, sir.
How's it going?
Good evening.
Very good.
So I'm new, so I don't know how to do this.
Okay, cool. So I'm going to go through this first one. What you do is, because tan is positive in the first question, all you need to do to find the reference angle is go shift tan 2.2156, and you should get an answer of 65.71. Okay. Now, if we were making this, in fact, you know what, for today, I'm actually not going to do the general solution. So basically, it's actually easy for this one over here, because tan, you can see my solution is 65.71. Normally what we do is we would add on something where we'd say, we use something called the cast diagram, and we ask ourselves, in which quadrants is tan positive? And tan is positive in this quadrant, and tan is positive in this quadrant. Okay, but all the angles in this quadrant have that form, 180 plus x, where x is the reference angle. And this might be a little bit overkill. You might need to go back and watch the earlier videos. But basically, each of these quadrants has sort of a standard form. Now, because I've got my answer of 65.71, I'm happy because that is one of the answers. The other answer is in quadrant 3, which is down here. But because it's of the form 180 plus x, it's going to go outside this range of 180. So I'm not even going to worry about it. I'm just going to leave it like it is, and the answer will be 65.71. Does that make sense? Sort of. Okay, I want to see if the answers for the second one are coming in, because I'm going to do the same process again. And then you'll understand what I mean, because it's this repetition that you need. So for 5.2, what we have is we ignore the negative to find my reference angle. And if I ignore the negative, I go shift tan 0.1378. Now that gives me 7.84 degrees, 7.85. The problem is that is not my answer. Because this is tan is negative, I need to use the cast diagram to help me. And so what I'm going to do is ask myself, where is tan negative? And tan is negative in, well, basically the two quadrants that I haven't rubbed out, right? And in these quadrants, the answers are going to be 360 minus whatever my reference angle is. Now, in this case, the reference angle is 7.85. Or in this quadrant, the answer is going to be, I'll just get rid of the S for a second, just because there's too much going on. 180 minus whatever the reference angle is. Now, both of these solutions are valid. The solution in quadrant 2 and the solution in quadrant 4. But this question is only asking me for answers in that part. And so I'm only going to worry about the solution here. And so the solution for alpha is going to be 180 minus 7.85, which is going to give me 180 minus 7.85. It's going to give me 172 degrees 0.15. Okay, so that is the method. But are there questions? I know if there are new students here, I might have lost you. For those who are feeling very comfortable and just want to practice, I want you to keep going and try and do 5.3 to 5.5. But notice that there are some tricky little bits like this bit over here that pops up and also this bit over here, which I want you to think back in class. But for those students who weren't with us when we did this module a couple of weeks ago, I really like to hear your voices and hear your questions about how you would start 5.3. What do you think? Let's have a dialogue. How would you start 5.3? If you're new here, no judgment, jump on the line and let's have a discussion about, and we'll talk through 5.3. Okay, good. I love it. Divide by 2 first. You're absolutely right. You must divide by 2 because you need to, that makes life difficult. So step 1 is going to be to change this question to the sign of theta plus 20 equals whatever 1.8976, so 1.8976 divided by 2, it's going to be 0.9488. But we're not done. We need a next step. What is my next step going to be? From the chat, or if you feel like putting your hand up, what's the next step that I have to do? Okay, so you need to find your reference angle. Yes, so you find your reference angle and you don't have to ignore any negatives this time. You go shift sign 0.9488 and you should get a reference angle of 71.59. But the problem is the reference angle is not any reference angle, okay? It's going to be theta plus 20. So we need to bear that in mind that, you know, that's going to be part of it. Okay. But let's ask ourselves something else. What quadrant is sine going to be positive in? It's going to be positive in this quadrant and it's going to be positive in this quadrant. So what I'm going to do is I'm going to say that theta plus 20 is equal to 21.59. And that's going to be for quadrant number 1. Okay. Now, what you'll notice is that I could also do quadrant number 2's answer, but in this particular question, can you see it's only interested in the answer between 0 and 90? And so I'm going to ignore the second quadrant for now, just because they're only interested in my answers between 0 and 90. So what do I need? And the other thing I want to point out that students often get confused about is notice how the theta plus 20 is now almost replacing like where the reference angle is. Okay, so what do I need to do as a last step? What do I have to do about this plus 20 over here? Yeah. So you take away 20 from both sides, and you're going to get theta. Oh, how did I find the reference angle? So Teddy, I went shift sine 0.9488. And you should get 71.59. Be careful, Katlejo. Instead of being plus 20, oh, did you get something different in quadrant 2? Let's do quadrant 2 just in case. But you should get over here, you should get 51.59 for theta, because you take away 20. I'm pretty sure that in quadrant 2, you wouldn't get that, but let's just have a quick look at what, if I did this, the half of the solution, which was in quadrant 2 solution would be 180 minus theta plus 20 equals 0.9488. Sorry, equals, I lie, equals 71.59. And I'm pretty sure you can see that as I start solving this, the values are going to be too big. So just to point out, there was a question about saying that the answer in quadrant 2 might be within the range. All I'm doing is I'm saying 180 minus, oh, I see what you mean. Okay, let me come back to that one. I don't want to go down that rabbit hole right now. For now, I'm happy that most students have got the method there. And I'll just need to check on that one. Okay, let's try and do 5.4 together. What is the sine of beta over the cos of beta? And then we must move on to the identity question. We don't want to spend too long on this, but what is the sine of beta over the cos of beta the same as? In the chat. It's the tan of beta, yes. So if I rewrite question 5.4 as the tan of beta equals 0.2346, then I'm good. Now I want you to find me the solution to the tan of beta equals 0.2346 using your knowledge from this particular question. But bear in mind, I'm only interested in the answer in that section over here. So because it's positive, it's all good. We go shift we go shift tan 0.2346, and we get for beta 13.2 degrees. Perfect. Yeah. Now, in this particular question, again, there are other answers, right, to these trig equations, but tan is positive in this quadrant, and it's also positive in, sometimes people also like to do a little tick. Now, we've got the answer in quadrant 1. If we wanted the second answer over here, it would be of the form 180 plus the 13.2. But because we're only interested in answers between 0 and 180, I'm just going to ignore that. So Nortila, be careful. Tan is positive, and so tan will have to be in quadrant number 3. Give me a thumbs up if you know what I mean. Like, if we go back to the cast diagram, and this tells us where the trig ratios are positive, tan is positive in quadrant 3, which is this one, and positive here. Okay, so that's why we can't go 180 minus. Okay, so what I'm going to do is I'm going to encourage those of you who are new here and have feeling like, oh my goodness, this man's going at 100 miles an hour. I did some really great videos on explaining trig equations. And Lebo, I don't know if you have access to those links, but the website definitely has them. And I would recommend going to have a look at those. But I'm going to move on now just because of time. And I want to finish today with these 2 questions. All right. So what type of questions are these before I let you loose on them? The very first one is a trig reduction formula question, and it's worth 7 marks. The second question is an identity question where you have to prove that the one side is equal to the other side. Give me a thumbs up if you have seen these at school. I just want to make sure everyone in the room has seen these at school. Now, I'd love to hear a voice that would share some of the strategies that you think I'm going to use as I go about 5.2. So I just want some hints, like what are some of the things, I'd love someone to put their hand up and just tell us, what are some of the strategies you think we're going to use for everyone's benefit before we start? Does anybody feel like they would be willing to? Okay, Erin, I'm going to unmute you. Okay, go ahead.
So we will first reduce it by, normally I reduce it with using the CAS diagram. So
Yes, the CAS diagrams can come up. Which of the ones that are there, what do you remember about the CAS diagram? Like, how do you use it? Just give us a quick reminder.
So we will just put the values where
like 315, where would you put, how would you do tan of 315?
Oh, it's gonna be 360 minus 315.
Yeah, because 315 gets you to here.
Yes.
Okay, perfect. And so, for example, in this quadrant, is tan positive or negative?
Negative.
It's negative. So we know that the tan of 315, oopsie daisy, 315 is equal to negative tan. And then how did you get the angle?
360 minus 315, so it's going to be 45.
Yeah, so it's how far away is it from the nearest horizontal, and it's going to be 45. Okay, see what you guys can do on 5.2, and then I'll give you some of the answers in a second. But see how you do out of 7 in using the reduction formula on this. Muzi, let me unmute you. Yeah, go ahead.
Yeah, so what I did sine 60. It was sine 60.
Okay, so
simplified it.
So your first bit was sine of 120 reduces to sine 60, yeah?
Yeah, and then I did bracket minus cos 30.
So you got minus cos 30. And again, for those who are confused, what Musi is doing is he's saying, look, I know in this quadrant that cos is negative. So that's why he's got minus, and it's cos 30 because 210 is 30 away from the horizontal. Okay, go ahead, next one. And
then I close bracket.
Yep.
And then I do another bracket which has minus tan 45.
Okay, perfect. I'm going to stop you there, Muzi, for now, but thank you. That's fantastic. Now, the question is, there's still different parts of this thing left. I want to give a little bit more time to students to just think about that. But I think the cos of 27 is going to be interesting to deal with. And I'm just going to ask for now, just to give a little bit more time for students to think about, okay, well, how do we reduce, give a little bit more time. So these ones down here are a little bit sneaky. And how would we reduce the cos of 540? So Notile, I agree, special angles are going to come in at the end. But I want to first simplify this whole beast, because the other thing I haven't pointed out is that you do it without a calculator, which means there must be special angles involved. but we need to try and figure out this 540. So Notila, I'm going to unmute you because I can see that your hand is up. Do you want to help us with the 540?
No, sir. I wanted to ask a question. If is it correct if I use 270 minus 60 on the
Yes.
cos minus cos 30? I used negative cos 60. Is it okay?
Okay, so are you talking about the cos of 210?
Yes, sir.
Okay, if you go to 270, you have to use what's something called the co-ratio. And so that would end up being minus the sine of 60. So whenever you use a vertical, whenever you use a 90 or 270, it's going to end up being, it has to change from a cos to a sine. Did you do that? So Muzi, I lost you there. Did you?
It was Notile. She put her hand down.
Okay, so if you're going to do that, then you have to make sure that you change it to, but I would say where possible, always use the horizontal. Okay, so let's have a look at the cos of 540 is just going all the way around to here, and then we get to here, and then we get to here. So really, basically, it's on the actual horizontal. And so this is a special type of trig ratio. Now, you're not, okay, what I'm going to say to you is this. You're not meant to use your calculator, but when it falls exactly on the axis, it's only going to have three possible values. It's going to be 0, -1, or 1. And it's there's no marks. You have to, essentially, you can get that value straight from your calculator. And because it is over here, the cos of 540, the cos of 540 actually ends up being -1. So you should use special angles, and there are sort of artificial triangles that you can use, but in reality, there's only one mark allocated for that. And so if it falls exactly on the horizontal, so for example, another one like this would be the sine of 360. Or what you can do is you can use the cos graph to think about it. But in a practical way, students just need to know what the value of the cos of 540 is. And it's very hard to have a special triangle for one that forms exactly on the horizontal. Okay, so what I'm going to say is that. Does anybody have an idea about how we deal with the sine of 63 and the cos of 27? So in this case, we have no choice. These two are related by a co-ratio, essentially. And so what I'm going to do is I'm going to say, remember earlier on I said, if you think of sine of 63, which is here, how far away is sine from the nearest vertical? Now, the nearest vertical is in fact 90 degrees. It's here. And what I'm going to do is I'm going to say, look, sine in quadrant 1 is always positive. So this thing has to be positive. But if I reduce it off the vertical, I'm going to have to change this from sine to cos. And then I just say, how far away is it from the nearest vertical? And in this case, it's going to be 27. Now, guys, why is it so nice to have cos 27 on the bottom? In the chat. Co-functions, yeah. So I don't want to stress, yeah. Why would it be so helpful? Yeah, so it cancels the top one, exactly. And so what happens is that this is going to cancel that. Now, all we're left with then is the sine of 60, and then the other thing, you can cancel Notile, yes. If it's exactly the same thing, the one on the top and the one on the bottom, it will be equivalent to 1. Okay, so now what we next have is a theme of this lesson has been double negatives. What happens if we have two double negatives? It's a positive, yes. So all we have to work out to finish this question is what is the sine of 60 times the cos of 30 times the tan of 45. And this is where we need what's called special triangles. And so there's two special triangles that you need to know. And you just write them down on the side of your paper here. So this is going to be 2, 1, and this is going to be 1, 1 root 2. And you can then use these special triangles to sub in for values here. Now, because of the time issue, guys, what I'm going to do is I'm just going to bring the answer onto the screen now, because I think that otherwise it's just going to take forever for us to get through this one. And this is the last one of the day for now. We're almost out of time. Just want to see where it's come from. Let me have a quick look here. I'll bring it on screen. Apologies if it's getting a bit all over the place. But basically, this is what you have here. So in the very end, you'll notice that we essentially canceled out those two, and these two negatives over here had to go away. Now, when we use our special triangles, so for example, 45, 45, 1, 1, root 2, and then the other one was 60, and that was 30, and so that was 2, this was 1, and this was root 3. If I'm evaluating the sine of 60, the sine of 60 is just going to be O, so root 3 over H, which is going to be 2. And that's where the root 3 over 2 comes from. And all we have to do then is we plug in these values, but we need to draw our special triangles to show evidence of where we came from. Notice how all we needed to do for 1 mark for cos 180 was to find -1. And that's why I was suggesting just use your calculator for that. Even though the question says no calculator, there's only 1 mark allocated, so you can't essentially lose that. Okay, so we're pretty much out of time, guys. I just want to get a quick feel for this question. Are there any remaining questions or places where I've lost you before I wrap the session up? So in this question, we basically went through and we reduced all of these. There was one tricky bit where we had to use the co-ratios over here, and then we had to use special triangles. But I just want to give an opportunity for any clarifying questions before we wrap up the session. Okay. So how is it -3/4? So in this particular situation, what you have is you have 2 negatives on top, and what that's going to give you is a positive. And then because there's another negative on the bottom, those two interact to give you the negative here. So I hope that answers the question. So these 2 negatives on top cancel each other out and give a positive, and then below you get a negative. So what I want to show you before we finish the session is what you're going to get from the Watobe website now. And next week, we're going to carry on a little bit with some of the stuff that we haven't got to, but all students are going to get this. So for example, in question 5, there's the question, there's the answer below, the memo. And for the questions we were doing here, I'm going to send you this. And for the question that we just did now, you can see that, but I also have the answer for how to do the trig identity below. And so I just want to let you know that even if we haven't covered all of the work, I gave you more than we were going to be able to do in the hopes that you could use it for practice material. And so I just want to finish today by doing another poll, because I know I'm sure you guys have been working hard, and if you're keen to finish off now, I just want to ask, how did you find the lesson pace? I'm just going to relaunch the poll. And if you could just assist us by showing us, like, how did you find today? Was the pace right? Was it too fast? Was it too slow? And I just want to get a feel for the group. Okay, cool. Fantastic. All right. Thank you guys for all that feedback. That's very helpful. And then, are there any other comments or questions you want to make before we finish, or to put it in the chat? Otherwise, we're going to wrap this session up.
There's a question from Notile, Mr. S.
Okay, Notile. Go ahead, Notile.
Okay, seem to have lost her.
Okay, I'm trying to unmute her, but it doesn't seem to be. There we go. Yeah.
Sorry. I wanted to ask if you were going to send the whole memo.
Yeah, I'm going to send the whole memo. In fact, it's going to be uploaded onto the Watobe website right now. And so if you go to the course, you should see that. We can go through the other questions next week. Based on feedback from students, we'll do whatever is most useful. But I think probably I'm going to go through some of the questions next week. Even though the answers have been done, I just want to take a few comments on that. There was another question about nature of the roots. And I just want to point out that nature of the roots, I put some exam questions in here on nature of the roots, showing you what a typical nature of the roots question is like for that student who was asking. Okay. So I would suggest heading to the Watobe website now, and then, yeah, we'll carry on with this. And we're also going to do, basically, I will carry on with this next week, and we'll do some circle geometry. But if you are very, very keen on a particular topic, just let me know before we log off now. So just let me know now, like, what that topic is. And I hope that was helpful. And I think, yeah, we've worked hard now, so it's time to take a break. Thanks, Cameron. I'm glad you enjoyed it. Functions, okay. We'll see if we can do some. Bye, Emmanuel. Bye, Muzi. Pleasure, Nomple. I'm glad you enjoyed it. I'm glad you enjoyed it. Lebo, anything from you?
No, nothing from my side.
All right. So,
sorry,
yeah.
Mr. S. I just wanted to mention, I forgot to mention that if, I don't know if you mentioned it already, if anyone needs to touch up on a few things, basic algebra or factorization, they can go revisit the old lessons.
So yeah, so this is for students who are really struggling with a particular topic. So I did sort of mention it, but for example, trig equations, if you found like today I was going way too fast for you guys, we have done lessons on trig equations in the past. And if you find them on the Watobe website, it can be very, very helpful to go through a couple of those lessons because we really try and go into detail. Whereas today, because we're doing a broad swathe of topics, it's quite important that, yeah, we try and get a balance, but we probably go into a bit more detail in those. All right, Lebo, I think it's time to bring the show to a close. Thank you so much for your help. And yeah, if you have any feedback for me, then just pop it maybe in the Slack channel. I've got the poll results, so that's fine. And yeah, we'll go from there.